गुर्बत में हो अगर हम रहता है दिल वतन में, समझो वही हमें भी दिल हो जहां हमारा. Thank you for inviting me to celebrate the life and achievements of Mrs. Tehrim Das. Freshly liberated from the shackles of British colonial rule, she forged the way for girls like me, born in independent India, to hold our heads up high, believe in ourselves, and compete with the best. As one born and raised in Lucknow, Avadh Girls Degree College is particularly close to my heart, since I was a student of its predecessor, Loreto Convent College. I would like to briefly share with you my journey from Lucknow to NASA headquarters, Washington, D.C., where I'm currently Deputy Program Scientist of the James Webb Space Telescope, of the obstacles I had to overcome to achieve my dream, and finally, give you a glimpse of the exciting science that this telescope will deliver. As I wait to see the wonders of the universe that this telescope revealed to us, I look back to the time when I gazed at that same sky as a little girl in Lucknow. My favorite rhyme was "Twinkle, twinkle, little star, how I wonder what you are." That wonder carried me through my childhood, gazing at clear night skies, seeing Sputnik in the early morning sky over Lucknow, following the space race between USSR and USA, and devouring all the science and mathematics I could learn in school. My path to my dream of pursuing astronomy was not straightforward. At every crossroad in life, I had to make decisions based on the situation I found myself in. The lesson taught by my class teacher in Loreto to work hard and have faith in myself gave me the strength to make bold decisions later in life. So when I joined Loreto Convent, science wasn't offered as a stream in the senior classes for the school leaving exam. But when I reached class 9, we had a new headmistress, Mother Bernadine, who had just returned from the United States. And she had this revolutionary idea that girls could do science. And much to the thrill of my classmates and me, she introduced science in the school for the senior Cambridge class. And we were fortunately the first class to benefit from it. It was a challenge both for the school and for us, because in those days, finding women teachers to teach science was really hard. With the dedication of the teachers and determination from us, we did extremely well. And all of us, the handful of us who had chosen to do science, first division in our senior Cambridge. I completed my intermediate at Loreto Convent, and then I had to decide what to do next. I was determined to do mathematics, but at that time, none of the English medium colleges in Lucknow offered mathematics in BSc. So I took the plunge and joined Lucknow University. This was the first time I left the protective environment of a girls' institution and went out into the world. I wanted to take astronomy as a subject in BSc, but I realized that for astronomy, it was required to go out at night to make observations, and my family wouldn't allow me as a young girl to do that. So I completed my BSc with physics, chemistry, math, 5th position in the university, and then decided I wanted to go for further education. And so I joined Aligarh Muslim University for a master's in physics, and I got first position, and I went on to do an MPhil in physics. I still remember that one rainy afternoon in Aligarh in the university, I suddenly decided that I would pursue my childhood dream of following my uncles and granduncles to Oxford. I thought it was an impossible dream, but I decided I would pursue it. So to cut a long story short, I got admission at Lady Margaret Hall in Oxford. At that time, it was an all-women's college, and I won the Commonwealth Scholarship, which enabled me to get DPhil, which is what PhD is called in Oxford, in theoretical nuclear physics. At that point, I decided I would come back to India, and I got a visiting scientist position at the Tata Institute of Fundamental Research in Bombay. From there, I got my dream job at the University of Pune as a faculty member in the physics department. And then I reached another crossroad in life when I had to make a difficult decision. Under pressure from my family, I was asked to choose a husband. I made it clear to my parents that my future husband would have to agree to me continuing my profession and would have to treat me as an equal and a partner. I was fortunate to find such a person, and I married Dr. Aftab Ansari and followed him to the United States. I started postdoctoral research at Duke University in Durham, North Carolina, and till I saw a new opportunity which required me to change my path. I got a National Research Council Fellowship at the U.S. Environmental Protection Agency in North Carolina to study the visibility degradation effects of aerosols. After completing that project, we returned to India with our infant son, Sadiq. I went back to nuclear physics at the Bhabha Atomic Research Center in Bombay. After 2 years, we crossed the Atlantic once again and found ourselves in Baltimore, this time with 2 infant sons. With support from my husband, I accepted an offer from Space Telescope Science Institute in Baltimore, which was a newly formed institute by NASA for the science operation of the soon-to-be launched Hubble Space Telescope. I had the duty to write optical simulation software for the Hubble Space Telescope and its science instruments. After the Hubble was launched, I was made the telescope scientist, and it was my duty to keep the telescope in focus after the flaw in its primary mirror was discovered. After the servicing mission and the optics of the Hubble being fixed, I decided it was time for me to make a change again. So I accepted a job as a visiting senior scientist at NASA headquarters, Washington, D.C., in 1994. NASA wanted me to stay on, and in 1999, I became a civil servant. I have worked on a dozen astrophysics missions as program scientist, spanning the whole range, wavelength range from X-rays to ultraviolet to visible to infrared, and right up to gravity. Here on the left, you see me standing in front of the gold-plated primary mirror of the James Webb Space Telescope when it was assembled at Goddard Space Flight Center, Maryland, which is close to my house. And I'm standing outside the viewing window of the clean room where the mirror was assembled. The lower picture, I am standing with a group of teachers who flew on the Stratospheric Observatory for Infrared Astronomy, or SOFIA. This is an observatory in partnership with the Germans, and it was an observatory inside a 747 airplane, or a jumbo jet, which belonged to the US passenger airline Pan Am. And when Pan Am went out of business, it sold that plane to NASA. So we have a flying observatory, which is soon to end its operation, but it has been flying for almost 10 years. And on the top, I'm receiving Exceptional Achievement Award. So now let's go on. Let me give you a glimpse of the science and engineering of the James Webb Space Telescope. We think of it as NASA's infrared eyes on the universe. It's a partnership between NASA, the European Space Agency, and the Canadian Space Agency. Webb is a technological wonder. It will enable humankind to unlock mysteries of formation of the early universe. It's a tribute to the ingenuity and creativity of the human mind. With its 6.5-foot primary mirror and 4 powerful science instruments, it will study the first stars and galaxies, atmospheres of extrasolar planets, learn where elements that form life came from, and much more. On the left-hand side picture, you see Webb telescope, the golden primary mirror folded back. On front of it, the secondary mirror is folded back. The science instruments are at the back. And below it is a 5-layer sun shield made of a material called kapton, and it's the size of a tennis court. Now, a telescope this size cannot fit in any available rockets, so the telescope and the sun shield are folded back for launch. And on the right, you see the telescope and sun shield folded up. Webb will help us look back in time, and that's because the light, which is arriving at Earth from the farthest objects billions of years ago, left those objects a long time ago. We see those objects not as they are today, but as they appeared a long time ago. So just to give you perspective, the light from our own sun left 6 minutes ago. So the light that we see from our sun isn't the light which left it a second ago. So the universe started when a singularity, which is really a very small, almost like a dot, containing the entire mass and energy of the universe, suddenly started expanding. Scientists call this phenomenon the Big Bang, not because there was a big loud sound, but because of the sudden releases in energy. They decided to name it Big Bang. Now, as the universe expands, the light also expands with the universe. It stretches to longer wavelengths. We call that the cosmological redshift. And here is a cartoon showing the light which left as blue light from newly born stars and galaxies. By the time it reaches us, more than 13 billion years later, when it reaches the Webb telescope, it will be stretched out in the infrared. Just to remind you what the electromagnetic spectrum looks like and where we fit in it. On the left side is the high energy, low wavelength gamma rays and X-rays. And then you go to the longer wavelength ultraviolet rays. And the visible part of the spectrum, as you can see, is really very, very tiny. And that's what our eyes can see. And beyond the visible is the infrared, then the microwave, and then the radio. And to understand all the different phenomena in the universe, we really have to see all the different parts of the spectrum. So to do that, we send telescopes into space because the Earth's atmosphere absorbs most of the wavelengths, and the ones it does let through are blurred. Figure you can see on the left is the Hubble Space Telescope, which is in the ultraviolet, visible, and a little bit of the near infrared. The James Webb is in the near infrared, mid and far infrared, and the Spitzer telescope, which was also in the infrared, but in a longer wavelength than the James Webb. So what will James Webb do scientifically? It will discover some of the first galaxies. In this image over here, taken by the Hubble Space Telescope, it's called the Hubble Deep Field, when Hubble was pointed at a patch in the sky for a long time, and it saw galaxies as far back as about 400 million years after the Big Bang. And the inset in this image shows a galaxy which was about 400 years back, and you can see that it's not very well formed. Here is what we call a flip book of galaxies over time. So these are a number of galaxies at different time periods, again taken from the Hubble Deep Field. We can see that they evolve in time as they go from early on to today. So what Webb will do, it will examine different eras in time, and it will provide us essential insight and help us learn about how the galaxies evolve. They change over time, they grow, they collide, and they merge. So there's a lot of action going on in the universe. Webb will also re-examine how stars form, live, and die. In the two images here from the Hubble Space Telescope are in two different wavelengths. The one on the left is in the visible, and you can see that there are a lot of dust clouds which are blocking the light from newborn stars, which are being born inside those dust clouds. On the right-hand side is a Hubble image in the infrared. Long wavelength of the infrared penetrates those dust clouds, and you can start seeing the newborn stars in those dust clouds. Webb will have a much sharper images, and it will be able to see stars forming further back in time than Hubble can. Webb will also examine our own solar system from Mars and beyond, and give us details of what's going on over there. Here, as an example, is a picture of Jupiter taken in the infrared. And Webb will give us much more details of the atmospheres of these planets and the surfaces of the planets. Webb will also determine the chemistry of exoplanets, that's planets around other stars. We call those extrasolar planets. As the planet transits in front of its own star, the light from its star gets absorbed by the atmosphere of the planet. And if we look at the spectrum of this atmosphere, we'll be able to learn what the atmosphere is composed of, because every element and compound and molecules have distinct spectra. It's like a fingerprint, like every spectrum is like a fingerprint, which helps us identify the composition. So the instruments on Webb will be able to get spectra which will help us identify water, carbon dioxide, methane, and other molecules which could be present in the atmosphere of these extrasolar planets. And there are already programs which are planned, observations for studying these extrasolar planets. Webb will also dissect black holes. It will give us greater knowledge about black holes and perhaps tell us whether black holes came first or the stars and galaxies came first. So here is a quick summary of Webb. On the right-hand side is the figure of the telescope. The primary mirror is composed of 18 hexagonal segments made of a material called beryllium, which is light and very strong and doesn't change rapidly with temperature. And in front of the primary mirror is the secondary mirror. Then there's a hole in the primary behind which there's a tertiary mirror. So the light first comes on the primary mirror, then hits on the secondary, goes through the tertiary before going into the science instruments. Now the telescope and the instruments have to be kept very, very cold, because we do not want any interference from the infrared light emitted from the body of the telescope. So to keep the telescope really cool, there's a 5-layer sun shield made of a very light and strong material called kapton. And the bottom layers of the sun shield are coated with material which will reflect the sunlight. And so that will keep the telescope really cold. It's the size of a tennis court. There are 4 instruments. There's a near-infrared camera provided by NASA, built by University of Arizona, a near-infrared spectrograph provided by the European Space Agency, a mid-infrared instrument, a partnership between NASA Jet Propulsion Lab and ESA, and a fine guidance sensor and a near-infrared imaging spectrograph provided by the Canadian Space Agency. And the Science Operations Center will be at the Space Telescope Science Institute in Baltimore. And here on the bottom, I have shown the 4 science themes that Webb will address. The first light, the assembly of galaxies, birth of stars and galaxies and planetary systems and the origins of life. So where is Webb's orbit? Now, the Hubble Space Telescope orbits the Earth at about 300 miles from the Earth. But Webb has to be kept really cool. So it is placed in an orbit 1 million miles from the Earth. And it orbits a semi-stable point called L2, where the gravity of the sun and the Earth and the moon almost balance out. So it's a good place to place a spacecraft because it remains stable, and also it is far enough from the sun that the sun shield can keep it cool, and it's close enough to the Earth that it can communicate with it. And so the Webb telescope orbits the sun, L2 point orbits it. And since it is so far from the sun, it doesn't need a tube like a Hubble does, but sun shield acts like an umbrella to shield it from the heat of the sun and the Earth. So here is a larger image, which I've shown you earlier, just to give you an idea of how big the mirror is. You can see the man standing there, how small he looks compared to this telescope. In the Northrop Grumman facility in California, where the telescope and the spacecraft were put together. Webb started its journey in a very special container which was built for it. It's called the Space Telescope Transport for Air and Road, or STARS. And so it starts its journey from Northrop Grumman's Space Park facility. And this transporter is so wide that they had to close the streets in Los Angeles through which it had to go. So it went at night. It was specially escorted and taken to the shipyard, where it was placed in a ship called MN Colibri. The cargo was specifically designed for the Webb container to fit in it. Ship went through the Panama Canal, and here it's showing it approaching Kourou in French Guiana in South America, where the European spaceport is and where it was launched from on a French Ariane 5 rocket on December 5, 2021. Ariane 5 put it in a perfect orbit to its final destination in L2, 1 million miles from the Earth. And now we know that the Webb is getting ready to do science. Here's a picture which was released by NASA on April 28, showing that all 5 instruments have now been focused and are able to get sharp images. Now the various modes of the instruments are being checked out, and the mirror is still being cooled. It isn't fully cooled. And so all various checkouts are being made. And by next month, Webb should be ready for science, and we should be able to show you some nice science images. So I would like to end with a tribute to Mrs. Tehrim Dass. One slide cannot do justice to the tremendous work that she did, but this just gives you a little bit of a vignette of some of her amazing achievements. She was a chairperson of the Mother Teresa's co-workers in Lucknow, and on the left-hand side, you see her with Mother Teresa, who is now a saint. The middle picture is a vignette of some of her activities. She was a president of the Lucknow YWCA, and in that capacity, she worked to expand literacy, healthcare, sanitation, and hygiene in the rural areas. And you see her in the top left-hand picture of this collage, working in the villages. She was also founder and president of the Cheshire Homes. And in the middle picture, in the bottom of this collage, you see her over there at a function for the Cheshire Homes. She was president of the UP Women's Cricket Association. And you see her there on the right-hand side at the bottom. And she was given a Lifetime Achievement Award by the Lucknow Management Association in 2013. The Hindustan Times recognized her amazing work in a memorial in 2015. which a life well lived. An absolutely amazing lady who's been a role model to all of us.
Good morning, ma'am. And good morning, everybody present here. My question to you, ma'am, is that what was your motivation throughout this journey? As you may have faced a lot of obstacles through this very difficult journey and reached this place. So, what was your motivation throughout?
I was always fascinated by nature. I wanted to understand how the world works, and I didn't want anything to stop me. And I really loved mathematics. I loved physics. I was always eager to learn. And I would say that was my motivation, the curiosity.
I just wanted to ask that is there any advices for all the young girls who are present here so that we can be motivated? And
My advice is not to give up your dreams, to work hard. If you need help, seek help. Find a mentor, find someone who can give you advice when you need it. Keep focused and work hard and just pursue your dreams. Don't let anyone say you can't do this. As long as you feel you can do it, yes, you can do it. You'll have to figure out how to do it. That may not be easy. That part you have to do, how to do it. And for that, as I said, find a mentor, a parent or an uncle, aunt, a teacher or a senior student who can guide you.
I just wanted to ask, you just said that we need good mentors for our life. And what about we do not find such mentors throughout our life? What should we do then?
You should be able to find a mentor. Start with your teacher or start with your parents or an older brother or an older sister. It is sometimes hard to find. I would say start with your teachers. They can suggest somebody if they can't do it themselves.
My name is Safina. I'm in MS semester 4, and question is generally people consider women intellectually inferior. Have you ever faced such situations?
I personally have never felt inferior myself, so I don't see it when people say that, but there definitely people will tend to treat women differently from men. So, for example, when I was younger, they would often, if I was at a conference, they wouldn't even talk to me. They would come and talk to my male colleagues and not to me. So that kind of discrimination certainly happens, and it still happens. It's, I think, getting a little less now in the United States, where the women have been taking a stand. But as I said, have faith in yourself. Nobody will make you feel intellectually weaker than them. If they try to make you feel that, then it's their problem, not yours.
One more question from our college is that what path would you suggest for a budding scientist?
There are a lot of fields a scientist can go in. So it really depends on what your interest is. If your interest is research, that you really want to spend the rest of your life researching whatever interests you, then go into the research field in the university or in a research institute. Or if you want to apply it, again, depending on your field, you can go into industry. If you are, like physics, or you can become an engineer, you can go into engineering, or you can go into space science. Or what you can do, if you're interested in law, you can go in for intellectual property law. If you have a PhD in a science degree, you can go into intellectual property law. So, or you can become a science writer. So there are really a large number of fields a scientist can go in. Once you have your science degree, you can do almost anything after that. You have the value of critical thinking. That is what you really learn the best in science and engineering, is critical thinking. And after that, you can apply it to anything. So you can go on to become a doctor, You can become an engineer, you can become anything. And as I said, if you want to remain in pure research, then you become a research scientist who go to a research institution or to a university.
Ma'am, can a humanity or psychology or a designing student get into astronomy? Or what is the path they should take to move ahead in this area?
Yes, certainly. We have artists who do space art. We actually had art competitions for the James Webb, and we need a lot of science writers. So if you're good at writing, you can certainly be a science writer. So here are some closing remarks. I encountered many obstacles on my path to achieving my dream to do astronomy and to work at NASA. I couldn't have done it without the confidence instilled in me by my parents, my teachers, uncles, aunts, professors, and all elders. So I would like to say to the young women out there, have confidence in yourself, get a good education, stand on your own 2 feet, for that is the only sure way to get independence and empowerment. They say that the hand that rocks the cradle rules the world. I learned as a senior executive fellow at Harvard that there are no right answers and no wrong answers. You have to find what is the right answer for you. Whether you decide to be a wife and a mother, a professional, or both, that decision must be yours. But for true empowerment, we need to get partnership and mutual respect from our men. I was really fortunate that my father was truly fully supportive of me and encouraged me to go to higher studies, did not persuade me for an early marriage. Very few girls in my generation even got bachelor's degrees, leave alone masters and PhDs. I was fortunate also with my husband, who treated me as a true partner. Go out, don't give up your dreams. Only then will we fulfill the dreams of visionaries like Tehrim Dass, who opened the doors for women to take leadership roles. So ladies, fulfill your dreams and reach out for the stars. Thank you.